Hi guys, so this is lesson number 3, our last lesson of the week. I'm going to keep going on with algebra, correct the homework from lesson 2 and go on and finish off. Well, not finish off, but do another bit more, one more concept. I've said this in the videos, I've said this in the lives, this is difficult. This is not easy. Algebra is never easy, to be honest with you. I've been doing it for 10 years now. And it's never easy introducing algebra. So if you're still a bit unsure, lost, not getting it, the signs right and what to do, and take your time, work through the questions. Don't be, stressing yourself out over it. Like I said, if it comes to the point where we're back in school now after Easter and there's still troubles, well, we'll throw on an extra afternoon class once or twice a week, and we get you up to scratch for the summer. But it's important you watch the videos, rewatch them if you have to. Battle through the questions. Don't give up. Use the examples from the OneNote to try the questions. It's only when you start to get them yourself, it gets easier. You won't learn by looking at them and watching me doing them. You have to do them yourself. It's much harder, obviously, on videos that I'm not in the room looking over your shoulder and checking your work and giving you pointers to get through questions. But we can only do our best. So we're going to go back to the OneNote, correct the homework. I'm going to show you one new thing, and we will call it a week then. I won't give you homework. I might give you something to do because it's going to be half an hour. So I might give you a couple of questions to keep you going for the rest of the hour for this lesson, but there won't be something to have to do outside of the hour. Okay. So, down, right. So this was the homework I asked you to do. So you just question 3 and question number 4. Okay, I'm just going to have to. I'm going to have no choice. I'm going to have to get rid of these examples on the side, so I can write there. So, but the ones I'm doing are identical anyway. So in case you're wondering, it won't make a difference. So I'm just going to get rid of those, so I can write on the side. Taking a bit longer than I thought. Anyway. Okay. Great. Right. So what we'll do is we'll have a look at these here, right? So we'll start off with A. We'll do them a bit quicker this time because we did a lot of these the last day. So this is question 3A. So 3A, our question is 2A plus 1 and A plus 1. So remember what we do every time, right? I'm going to repeat this every time. But I'm going to multiply my first number by my A and my first number by my second thing. Then I'm going to move on to my 1, that by A, and that by 1. So I'm doing 4 multiplications, give me 4 answers. So my first line of this, 2A by A gives me 2A squared. 2A by 1 gives me 2A. Plus 1 by A gives me A, or 1A. And plus 1 by plus 1 gives me, plus 1 by 1 is just 1, isn't it? Then I underline my things that are the same. There we go. So 2A squared, there's only 1A squared, so it's just going to be 2A squared. The 1, nothing I can do with that. And finish it off, 2A plus A gives us 3A. And that's part 3A done. Part 3B then, you can watch this again and go through it and slow it down if you want. You watch as many times as you want, obviously it's a video. Our second one is 4x plus 1 and x plus 3. So, same again, multiply my 4x. So first thing in the first bracket by the first one and the second one. Then take my 1, multiply that by the first one and the second one. And give me 4 answers again. 4x by x is 4x squared. 4x by 3 is 12x. Plus 1 by x is just plus x, or plus 1x. And plus 1 by 3 is just plus 3. Underline things that are the same. 4x, or x squared, there's no other x squareds. 12x and x. And the L3. So then we put down the numbers that we simplify. Plus 3, no change to those. Now add the 12x and the 1x gives me 13x. There's B done. Okay. Part C. This is all question 3 now. We have 3x minus 7 and 2x plus 3. We take our same process every time. We take our first number, first bracket, multiply it by the first number, and multiply it by the second number. Then we're going to take our second number in the bracket, minus 7. Be careful of that minus, by the first number and by the second number. So 3x by 2x gives us 6x squared. Remember, x by x is x squared. 3x by 3, by plus 3, all pluses again, is going to be 9x. Minus 7 by 2x. Well, 7 by 2x would be 14x. Because there's a minus here and no minus here, it's going to be minus 14x. And minus 7 by plus 3, well, 7 by 3 is 21. Minus by a plus is minus. Underline the things that are the same. There's my 6x squared. It's only x squared. My x's. And finally, my 21. Work them out then. So put down my 6x squared, doesn't change. My minus 21 doesn't change because there's only one of them. 9x minus 14x, this is like having 9 euros. Take away 14 euros is going to be minus 5 euros or minus 5x. Okay. I'll just do part E in here, and then I'll rub out question 3, because you can watch this in the video anyway, right? To leave me space to do question 4. So over here, I'm going to multiply my 2b by my 4b, and my 2b by my minus 2. My plus 3 by my 4b, my plus 3 by my minus 2. And that is going to give us, our first line is 8b squared. So 2b by 4b gives me 8b squared. 2b by minus 2 is going to give me minus 4b. Plus 3, I'm moving on. Plus 3 by minus 4b is going to give us 12b. And plus 3 by minus 2 gives us minus 6. Underline the things that are the same. See that I'm doing exactly the same thing every time. So once you can do one, there's no difference between them at all. So I have 8b squared. Nothing I can do with that. Minus 6. I can't add or take away that. And I have minus 4b plus 12b. So if I'm minus 4 euros or minus 4 balloons and someone gives me 12 balloons, well, I'm going to be up by 8 b's. There's our answer to that one. That's all question 3 done out there. And you should correct those in your own homework copy. And I should be able to see those corrections in the homework section of the OneNote, so I can see who's able to do what and who is struggling with which parts. Okay, again, I'm going to have to rub that out so I can fit. There's no other space really, is there? No, we try up above, right? We'll try question 4a up here. 4a. So 4a, these are the same again, right? So I might not do all of these at all. I might just do 2 of these. I might just do part A and part D. So I'm just repeating the same thing over and over again. So 4x plus 6 and 2x minus 3. So there's part A, and we do the hardest part. We'll do part D as well. So D is 3p minus 9 and 4p minus 2. Okay, put my brackets in. Now, so same procedure. 4x by the first one, 4x by the second number. Then the 6 by the first one, and the 6 by the second number. Same every time. Right, our first line. 4x multiplied by 2x is going to be 8x squared. 4x by minus 3 is going to be minus 12x. Plus 6 by 2x is going to be plus 12x. And plus 6 by minus 3, 6 by 3 is going to be minus 18, because you have a plus 6 and a minus 3. Underline things that are the same. There we go. And now do me adding and me taking away to simplify. 8x squared, no change. Minus 18, no change, because there's only one of them. And minus 12x plus 12x. So if you have a minus 12x and you add 12x, you're just going to get nothing. So there's no need for me to put anything in here at all. That's just going to be 0. So I'm going to get rid of that. I'm going to get rid of the minus 18 and it's going to move it across. That's it. Job done. D, exactly the same. So question 3 and question 4 are identical, except there's a few more minuses thrown in question 4. So 3p by 4p, 3p by minus 2, minus 9 by 4p, and minus 9 by minus 2. Right, so 3p by 4p is going to be 12p squared. 3p by minus 2 is going to be minus 6p. Minus 9 by 4p is going to be, well, 9 is going to be 36p. Because it's a minus and a plus, minus 36p. And minus 9 by minus 2 is plus 18. Underline the things that are the same. Same procedure, absolutely, every time we do these. Go back. It's going to be 12p squared. The 18 stays in. And if you have minus 6p's, say it was p as in cents, and minus 36, that is going to give you minus 42p. Job done. Okay, one more I just want to show you, because they're the same, they're identical, but I just want to show you one of them. So if you have something like this one here, this is not our new thing for today because these are identical. So I'm going to make that a bit small and bring it over here. So this is question 5e. Okay, so 5e, and you get something like 5a minus 2 squared. So the squared is outside the bracket over here, and you're wondering, what do I do with that? If you see squared, that means everything inside the bracket twice. The same way if I was to say to you, what is 2 squared? You'd say to me, it's 2 by 2. If I was to say to you, what is 6 to the power of 4? You'd say, it's 6 by 6 by 6 by 6, so 6 4 times. So up here, this example, we rewrite it. 5a minus 2 twice, or to the power of 2. So 5a minus 2, 5a minus 2. So you just write what's in the bracket out twice. And then you do exactly the same as we've been doing. I'll do it just for the sake of completion. Multiply your first number in your first bracket by the first and the second, and then by the second number. Then go on to your minus 2, multiply by the first number and by the second number. So 5a by 5a gives us 25a squared. 5a by minus 2 gives us minus 10a. Minus 2, we're onto here now, onto this one here now. Minus 2 by 5a gives us minus 10a. And minus 2 by minus 2, because the signs are the same, is plus 4. So our answer's got, we're going to underline, there's our a squared, there's our 2 a's, and there's our 4. So we're going to have 25a squared, the plus 4 goes down, no change to them. And if you have minus 10a and minus 10a, it gives you minus 20. Like that. Okay. Right, so you can ask me any questions about those. Like I said, we have to do this as a video today. Usually it would be a second live lesson because we're doing algebra at the moment, but it's subject reflection week for teachers, so I have meetings with the science teachers and maths teachers. But we can do all live next week. Anyway, so let's go on and look then at one new thing for today, right? One new quick thing. And we're going over these again. Now we go through the revision exercise nice and slowly, so we'll have a good chance of doing all these again, all the different types. So this is turning words into algebra, or algebra back into words. So you get things like this example here. If you have this brother, or this girl here, Molly gives her brother 2 sweets every day starting today. How many has she given her brother after 2 days, 7 days, and D days? Okay, so the way you work out 2 days, well, if you gave it 2 sweets every day starting today, well, after 2 days, they're going to have 2 sweets the first day, 2 sweets the second day, 4 sweets in total. Does that make sense? So 2 sweets on the first day, 2 sweets the second day, so 4 sweets in total. Over 7 days then, so they're going to have 7 times given 2 sweets, is going to be 14 sweets in total. Okay, that would make sense, wouldn't it? If you get 2 sweets every day for 7 days, 2 by 7 gives you 14. But this is when it gets a bit algebra-y. After D days, so we don't know how many days. In that case, we just put it down like it sounds. We have 2 sweets over D days, which just give us 2D sweets. 2 by D. They can call it D, they can call it X, they can call it P, they can call it whatever they want. But if you don't know, you just put down the letter the way it looks. We'll do one more example. It's kind of the kind of question, or 2 more examples of the kind of questions that they give us. If they have things like this, so have a look at this down here. This is student A thinks of a number and asks student B to think of another number. So here's student A. Student A picks a number. Here's all the numbers student A picked. And student B has picked numbers as well. And what they did was they totaled those numbers. So they added them up. So they added basically all these was going to be pluses here in the middle. And this is going to be your answer box down the end. So basically, if you add 3 plus 7, it gives you 10. 4 plus 11 gives you 15. What I'm trying to get across to you, and the important ones here, are these ones here. Because if you add x plus 3, you can't say, it's not 3x, that'd be x multiplied by 3. X plus 3 is just x plus 3. 7 plus y is just 7 plus y. Oh, they give you the solutions down here. Oh, grand. So you can see there, if you have 7 plus y, the answer is just 7 plus y, because they're different things, you can't add them. If they have p, and student B picked minus 7, the answer is just p minus 7. If they have x and x now we have something different. X and x gives you 2x. We've done those before. Last one. These are the kind of questions that would be on an exam. Mia is X years old. Okay, that's not good. Mia is X years old. Not giving us Mia's age. Ben is 5 years younger than Mia. Alex is 1 year older than Ben. Emma is 3 times the age of Alex. And there's a nightmare. They're not even giving us any numbers. They're just telling us younger and older and so on. We take it step by step. What's Ben's age? Okay. So if we start with Mia. Mia is X years old. So let's see where Ben is then. Alex is 1 year older than Ben. So Alex is 1 year older than Ben. Okay. So if we take Ben's age, which is Mia's age, minus 5 years. So we have X minus 5. So if we take, look, here's Mia is X years old. Ben is 5 years younger than Mia. So basically, Mia's age is X, and Ben is 5 years younger. So we don't know what X is. X could be 70. X could be 6. We don't know. But we do know now that Ben's age is Mia's age minus 5 years, because it tells us here that they're 5 years younger. And that's what I mean, putting it from words into algebra. The second one, Alex's age. Okay. It says there, Alex is 1 year older than Ben. Okay. We know Ben, here's Ben's age here, X minus 5. And Alex is 1 year older than Ben. So how would we write that? Well, we know we have X minus 5, and we have to, how long do we say? 1 year older and 1. So X minus 5 plus 1. So there we go, X minus 5 plus 1. And then we can, because we have X minus 5 plus 1, we can change that. So minus 5 plus 1 is going to be X minus 4. And that is going to be Alex's age. Emma's age. Emma's is 3 times the age of Alex. So all you have to say in there, Alex is X minus 4. And Emma is 3 times that age. 3 multiplied by. Times is multiplied by. So if we have X minus 4 for Alex, Emma is going to be 3 times that. So we just put the 3 outside, like that. So it's going to be, if you want to work that out, then it's going to be over here. So, oops. It's going to be 3 times X minus 4. When you multiply that out, it's going to be 3X minus 12 years. And we still don't know how old any of those are. We've no idea, because the X could be anything. Because the X is anything, we never actually work out their age. We just get an expression for their age. Okay, and what I would like you guys to do, I'll do one for you quickly, but what I'm going to get you to do is a couple of these for the rest of today's lesson to be uploaded. There's question 1 and question 2 and question 7 and question 9. So there's a type of each of them. And let's have a look at, I suppose, the most difficult one of them. Question 12, before we finish up. A swimming pool has a length of 5x meters. Here it is here. So here's a swimming pool. So not telling us the length of it. 5x meters. And a width of 2x minus 3. All right. Write an expression for the perimeter of the swimming pool. Remember, perimeter. If I was to draw a swimming pool like this, perimeter is that side, side 1, side 2, side 3, and side 4. So if I wanted to find the perimeter of a swimming pool, normally, I'd get my trundle wheel. I'd go all the way along that side, all the way around here, all the way up here, and all the way up here. And that would give me the perimeter. So the way you get that maths is side 1 plus 2 plus 3 plus 4. And that would give me my perimeter in, well, meters. In meters. They're after messing it up by throwing in a lot of algebra here. So write an expression for the perimeter. So we have to add up. And we'll know that if this side here is 5x, this side here is also 5x. It's a rectangle, isn't it? And if that side there is 2x minus 3, this side here is also 2x minus 3. So for part A then, what we're going to do is we're just going to add up all the sides. And we're going to write them out as it looks like. So we call this, what do we say? This is side 1, side 2, side 3, and side 4. Here's our 4 sides, right? We'll add them up. So let's write down side 1, 5x. Add side 2 to it, plus 2x minus 3. So that's side 1 done, side 2 done. What's side 3? 5x again. Done. And side 4 is going to be 2x minus 3. So we've added up. You see what we've done there? We've added up. There's side 1, there's side 2, there's side 3, and there's side 4. Now let's simplify that a bit down, right? So we've 5x, like 5x here, plus 2x, plus 5x, plus 2x. What's that added up to? That's going to be 14x. And let's do the numbers then. We have a minus 3 here and a minus 3 here. So there is the perimeter for 14x minus 6. Okay, brilliant. Now, that's part A done. There's part A done. Part B is looking for the area. To find the area of something, you have to multiply the length of a rectangle. You multiply the length by the width. Right, so get rid of this for a second. So what's the length of this thing? We don't know what the length of it is. We know they're telling us it's 5x. That's not a length, but 5x is the length that they're giving us. And that's the width. So this is going to be your L, and this is going to be your width. So the way we work out area is L by W, which means it's going to be 5x, which is the length, multiplied by the width, which is 2x minus 3. Remember how we do it? Take the number outside, multiply by the first, multiply by the second. So that's going to be 10x squared minus 15x. Is it 3? Yeah, that's a 3. Minus 15x. And that's it. Done and dusted. Area, length by width. So that's about half an hour. So what I want you guys to do, and sorry I couldn't do a live one today, but I will do 3 next week if you wish. And like I said, if this is still a problem for you, you're not to be worrying, you're not to be panicking. The fact that you're logging in and doing this and trying the questions is good enough for me at the moment. When we come back, I will fill in any gaps that are in your knowledge. It won't take time when we're in a classroom. It's just going to take 10 times the amount of effort when you're at home by yourself. You can't just stick the hand up and ask me on the spot when it's on your mind. But battle through the questions. Do your best. Give it half an hour, 40 minutes today, and then leave it till next Monday. And you can ask any questions then. So what you're going to do, 4 questions for you to try. Exercise 15.7. Questions 1, 2, 7 and 9. And I'll put that at the side for you to. Okay. Classwork, not homework. Lesson 3. Exercise 15.7. Question 1, 2, 7 and 9. And if you have any questions, if you're working through those and you're having real bother and you want to know the answers, you want me to do it out for you, just send me an email and I will do that, no problem at all, and I'll send it back to you. Or I can I've done for a few people, I've inserted an audio file into the book, into the class notebook here. So let me know, but you're not to be worrying, not to be panicking. We will get there in the end. This time 3 or 4 months, you'll be well able to do all of these. These will be simple, and you'll be doing much more difficult maths. Wondering why you ever had an issue starting off with algebra. It's the same for everyone. It's the same every year, but this distance learning makes it much more difficult. So well done. You're all doing fabulous, and we will get there. Okay, mind yourselves. Email me if you have a problem, and if not, I will talk to you in science. Bye bye.